functions, how we write them, graph them, and evaluate. So first things first is, what is a piecewise function? So it is just a function that's made up of a collection of other functions, so at least two, it could be more, and then restricted on the domain. So each function is restricted to a specific interval for the domain. So here's one example of a piecewise function. So we're going to evaluate this for some different values. So I'm just going to highlight this top portion in red. Okay, so that's going to be our red function, this 1/2 x plus 7. And then the bottom part, the negative x minus 3 squared, is going to be our blue function. So in this, this top 1/2 x plus 7 is just for the numbers that are less than -4. And the bottom function, this quadratic, is for our domains that are greater than 2. So I just want to kind of draw out our x values here so you can kind of see what's happening for the x values. So we've got this x value of -4, and we've got this x value of 2. Okay, those are the two kind of boundaries. So this red function is just for numbers less than -4. And then the blue function is just for x values greater than 2. So this is where our function is defined. So in this whole chunk right here, the function is not defined. There's no, those domain values are not defined. They cannot plug into either of these functions. So when we take a look at doing f of -10, -10 is definitely less than -4. So we're going to plug it into the red function. So we're going to do 1/2 of -10 plus 7. So half of -10 is -5, plus 7 is 2. On a graph, that would be the ordered pair -10, 2, if you were going to plot that point. -10 being your x, your output 2 being your y. -4, so if we're evaluating the function at -4, remember -4 is not less than -4, so it's not going to go into the red function, and it's definitely not bigger than 2, so this is actually undefined. Okay, so -4 will not plug into either. -4.1 is smaller than -4, so that one will plug into our red function. So we'll do half of -4.1 plus 7, which is going to give us 4.95. 0, not less than -4, not bigger than 2. So this one doesn't have anywhere to be plugged into. So this is undefined. 1.9 is also undefined because it is not bigger than 2. And if you look at this domain value, that kind of graph that I drew out, 1.9 would be right here, right? So 1.9 would be here. 0 would be here. Those are definitely not defined. And then 3 would plug into our bottom function because it is bigger than 2. So we would do 3 minus 3 squared. So 3 minus 3 is 0. Squared is 0. And then -0 is just 0. So that's how you would plug in given the actual equations here. So let's take a look at graphing. Okay, so if we're going to graph these, again, I'm just going to draw them out in different colors here so we can kind of highlight what each part is. So this top function, again, I'm going to do in red, and this bottom function I'm going to do in blue. So for this top function, okay, now this is linear, okay? So we've got a linear function. So you can just plot a couple of points and then do the slope from it. That's fine. You can also create a table. One thing you want to make sure of is that you always plug in the boundary point, okay? I know this says x is less than -1, so -1 is not defined here, but we need to plug it in to know exactly where it's going to go, and we will just do an open circle on the graph. So when you start plotting, you want to use the boundary point and then other numbers of that domain. So we want x is less than -1. So we'll do -1, -2, -3. Okay, so -1 plugged in here. So -1, -1 is 1, -2 is -1. -2 is +2, -2 is 0. -3 is 3, -2 is 1, and so on. Okay, so then we can start plotting this. So -1, -1. Again, we'll do an open circle for this one since there isn't an equal sign here. So -1, -1 is going to have an open circle. -2 is at 0, -3 is 1, and it's just going to follow this -1 slope all the way off our graph because we want all the numbers less than -1 plugged in here, so it would continue on. So then you can connect that with a line and do an arrow at the end. Then we'll go to this next part. Okay, so this next graph, again, so X and Y, you can plug in. So we're going to start at 5, and we want numbers bigger than 5. So I'm just going to do a couple of those. Okay, so plug in 5 because it's the boundary point. Again, it's not equal to, so we'll do an open circle. So 6 times 5 is 30, minus 32 is -2. Plug in 6. 6 times 6 is 36, minus 32 is 4. 7 times 6 is 42, minus 32 is 10. And we can plot these. So we'll go 1, 2, 3, 4, 5, -2. And again, that will be an open circle. 6, 4, 7, 10. Okay, and then you can just connect that with a straight line here. Whoops. And then again, this domain keeps going. It's just X is bigger than 5, so we'll put an arrow there to show that it continues on. And then again, we have this whole chunk of the domain that's missing. So from these two boundaries, right in between them, everything is missing. So those would be undefined values of our domain. All right, let's take a look at another one that has just intervals. So they're not full, they're not infinite intervals, they're finite intervals. And this one is going to be nonlinear. So this first one is not linear, it's an absolute value. So an absolute value, if you remember, is a V shape. So when you're thinking about this, it's going to be important that you get the values where it switches. So you'll want to plug in enough values, maybe even all of them, or if you know about absolute values, finding the vertex and making sure that you plug that one in. So this one doesn't have any transformations. So the parent function of an absolute value is at the point 0, 0. So we for sure would want to be plotting that. You want the two endpoints then as well. So if you were trying to isolate and just pick a few values, I would think about -7, the vertex, and then the ending point. So those two boundary limits. So absolute value of -7 is 7, absolute value of 0 is 0, absolute value of 4 is 4. So then you could plot those points, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. This is equal to this. Okay, we've got the equal sign there. So we'll definitely put a closed circle, plot the vertex, and then plot 4, 4. Which is also a closed circle because equal to. So since an absolute value has, just straight lines on either side of the vertex, then you're able to just connect these. You don't have to plug in every value in between. You certainly can. Absolute value of -1 is 1, -2 is 2, -3 is 3, and so on. And if there were a transformation here, so let's say you had the absolute value of x minus 2, then you would want to make sure your vertex is going to be starting at +2, the number that would make this 0. So in your table, you would want to have plugged in 2 and numbers on either side of that. All right, then this next one is just linear. So we can just plot the two boundary points because that'll be the starting and the stopping point. So we can just plot the 5 and the 9. So 5 minus 3 is 2. 9 minus 3 is 6. Plot those two. 1, 2, 3, 4, 5, 2. And closed circles on both of those because of the equal sign. And then 9, 6. And then just connect that with a straight line. Okay, and so you've got some missing domains here in between here. Nothing between 4 and 5 is defined. So 4.5 would be undefined. Anything less than -7 is not defined, and anything bigger than 9 is not defined. All right, then evaluating from an actual graph. Okay, so let's take a look at the graph. So this input gives you your x value, right? So this is your x value, and what you want is what the y value is when the x is 0. Okay, so here's the line x equals 0 right here. So we're trying to look at where the graph is defined on that line. Okay, so where do you see a graph on that line? So the graph on this line is right here. Oops, let me change colors there. Okay, so here's the output. So you want the y value here. So 1, 2, 3, -4. So that point is 0, -4. Next one, f of -6. So we'll go over to -6. 1, 2, 3, 4, 5. So here's the line -6. Where is the graph at? And it's right here. So that point is -6, and then 1, 2, 3, 4, 5, 6, -7. So the y value is -7 when the x is -6. This one is 1, so let's plug in x equals 1. So that line is right here. So now you want to be careful on this one. Remember that open circles are not defined. So where is the function defined along this line? That's at this closed circle at -1. Okay, so let me erase the rest. Let me erase that so you can see that again. Okay, but on this line, it's not defined here because this is an open circle. Okay, it's not defined here because this is an open circle. So this is where the function is defined. That's at a y value of -1. Then this is a composition of functions. So we start on the inside, which we just did. Okay, so we just evaluated this. So f of 1. Okay, so we would plug in here, substitute in f of 1, we just found out was -1. And then we would now evaluate f of -1. So now we would go to the line, to the x value of -1 and see where the graph is. So here's x equals -1. The output is -4. So on compositions, you just start on the inside and work your way out. Then we have writing equations of lines. Okay, so now you're going to need to do two different things. Take a look at the restricted domain and writing the equation. These two are both linear. So let's take a look here at this half. Okay, so this x value that it starts at, this is x equals -2. So that's our boundary line. And we have our graph going to the left. Okay, so we have all of these x values, okay, that are less than -2. And it's a closed circle on the -2, so its x is less than or equal to -2. Then you need to write the equation of that line. Well, it's a linear equation, so it's in y equals mx plus b form. So look for the slope. Okay, so let's count the slope on here. So here's a point it goes through, and here's one. So counting up 3 over 1. Okay, so that's a +3 slope. And now this one just has a restricted domain, so it doesn't continue all the way to the y-axis, but we can just continue it on to see where it would cross. So I'm just going to do the slope of up 3 over 1, up 3 over 1 until I hit the y-axis. So if this had a full domain, it would cross the y-axis at +10. So then that's your equation for right here. Remember that y is already written as f of x, so we just need the 3x plus 10 portion. So then writing this next part, okay, this is your x equals 4 line. That's where the domain starts. And we have the values that go past 4 to the right, so x's that are bigger than 4. This is an open circle, so we will not have an equal sign under there. So then we just need to write the equation. So we will count the slope here. So again, you've got this point and this point, so I can just count up 2 over 1 for that. So the slope is 2. And then you can continue backwards, going back to the y-axis so that you can figure out what the y-intercept would be. So going down 2 over 1, down 2 over 1, and just continuing that slope until you get to the y-axis, which would be at -7. So then that equation or that portion is 2x minus 7 for that domain value. So what's happening is you're just extending it as if it had a full domain. So if I just took this line and just literally extended it, that's where it would cross. Excuse me, at the y-axis if you could continue this on for an infinite domain. So same with this one. If this continued on, it would cross there. Another way you can do it is you could do point slope form. So remember, point slope form is y minus the y coordinate equals the slope times x minus the x coordinate, and just take any point on that line. Okay, so you could take either of these. So if you didn't want to keep extending this because it takes kind of a long time to get down there, going a bunch of doing the slope, you could take this point, right, any point on here, okay, but I'm going to take the point 4, 1, and I would just plug it in here. So y minus the y coordinate, which is 1, x minus the x coordinate, which is 4, and then that slope, which is 2. And then you could just distribute. So 2x minus 8, add 1 to both sides, and you get y equals 2x minus 7, which is the same thing that we got when we kept extending it to find out what the y-intercept would be.